Like I was just sitting there.
Okay. All right. Today we're going to graph what are called piecewise functions. So I need everybody paying attention to number 4, and it looks like this. All right, so we're going to graph this thing. Now, kids, they are called piecewise functions because they are graphed in pieces. This particular one has 2 pieces.
It's at page 10.
Okay? Now, I want you to forget everything else in the whole problem, Mr. Andrew. I want you to forget everything else in the whole problem and look at just this. Tell me what that looks like. It's the V. That's right, Delaney. It's this nice little V. So I want you with your pencil to draw that on your paper. If you do, that's how absolute values are. Now, if you are using a pen, you're going to be in trouble. You need a pencil because we're going to be doing some erasing on purpose. This is the whole V, but I only want a piece of the V. I want the piece of the V that happens greater than or to the right of this line. Now, this line is not an asymptote. This line is there because if I look at my problem, the pieces are determined at 3. 3 is the break point. I have one piece bigger than 3 and one piece less than 3. So I'm going to look at this absolute value picture, and I am only going to keep the piece that is where x is bigger than 3. That's right. This means go to the right. So I want the piece of the absolute value that is to the right of this line. And this is the line at 3. So I'm going to put an open circle. It's open because that's not or equal to, where my V crosses my dashed line. And then I'm going to erase all of this because I am only keeping the piece of the graph where x is bigger than 3, to the right of 3. This is your divider. 3 is your divider. I only want this particular piece on the right side. Now, what does x squared look like? A parabola. So I'm going to go ahead and graph my parabola. I'm just plotting a couple of points so I get a nice shape. There's my parabola. Keep it going here. So there's my big parabola. I'm going to get rid of some of that writing up there too so you can see a little better. That's a big parabola. Do you see how up here at the top the parabola crosses my line?
Yeah.
I'm going to put a solid dot at the point where it crosses the line. Do you understand why that dot's solid? Because for the parabola, it's or equal to. Now, I don't want the whole parabola. I want either the left piece or the right piece. Well, look, if greater than means right, what do you think less than means? Less left. So I'm going to erase everything on the right side of that line, and there is my picture. Now you can take this dashed line out too if it's confusing you. You have a piece of a V and a piece of a parabola. That's your picture. You're done. That's it. That's it. So instead of graphing the whole parabola and the whole V, you only graphed a little piece of each one. All right, let's try B. These are confusing, but they're not too bad. Okay. This time I'm going to have 3 pieces. Okay? And if you pay attention to what's going on over here, we've actually got 2 breaking points. 2 boundaries. We have a boundary at 0, and we have a boundary at 2. This one only had 1 boundary. This one has 2. We've got a boundary at 0 and a boundary at 2. So what does that mean? That means that I'm going to have a piece of the picture over here to the left of 0. I'm going to have a piece of the picture over here to the right of 2. And then I'm going to have a piece where? In between. See that? 3 pieces. A piece over here, a piece over here, and then a piece in between. All right. What's that first piece look like? What does y equals x plus 1? Forget about all the rest of it. Look at that. What does that look like? What shape? It's a line. So I'm going to graph that line. It's the identity lifted up 1. There it is. Beautiful line. I don't want the whole line, no. Kids, when I do piecewise functions, I only want a piece. Which piece do I want? Look right here. I want the piece that's to the left of 0. Now, here's 0. So I'm going to put an open dot right there where it crosses the boundary. And I'm going to erase everything to the right. There is the piece of the line that is to the left of the boundary. I have left and right. Less than means left. Let's skip down and do the bottom piece. What shape is that? You already told me. That's a parabola. So if I graph my parabola again, there's my parabola. I'm doing the bottom row, bottom thing down here. That's a beautiful parabola. But I don't want the whole thing. What part of that parabola do I want? Pay attention, what does it say? In between 0 and 2. So here's 0, here's 2. So I want the part of the parabola, just the part of the parabola that's between here. So I have a solid dot there on that boundary. I'll have a solid dot here on this boundary. And then I'll erase everything else. So I just have that little piece of the parabola in between my 2 boundaries. Yes, these look strange because we're only graphing pieces of them. We're not graphing the whole thing. All right, now what is this? That's a tricky one. It says y equals 3. Does anybody know what y equals 3 looks like?
Isn't it a string?
What kind of line, Philip? Horizontal line. So it's a horizontal line. Very good, Philip. Where y equals 3. So there's the line, the horizontal line where y equals 3. Do I want that whole line, though?
No.
No. In a piecewise function, I never want the whole thing, I just want a piece of it. Which piece do I want? Greater than 2. So here's my 2 boundary, and greater than means to the right. So I'll put an open dot right there where it crosses the boundary and get rid of everything to the left. I'm keeping only the part to the right. The picture is in pieces and we do it in pieces, one piece at a time.
So that is an answer.
That's your answer. Yep, all you're doing is graphing it. All right, there's one more. Let's try that one. Now this is an easier one because it's only in 2 pieces.
Sorry, sir.
Maya?
Can you keep like the entire line, but just like draw like where the open and close that is? Or do you
No,
have to erase
you
it?
have to erase Maya because if you kept the whole thing, let me go ahead and draw this part back in, for example. If you kept the whole thing, this guy would not be a function. He wouldn't pass the vertical line test. Remember that vertical line test? If I erase this, then it is a function because even though you got all these little pieces in there, nothing gets hit more than once when you draw on a vertical line. Does that make sense? Okay. All right, now, let's see if we can sketch this one. Where's our dividing line? Where am I going to put my dash line this side? 0. At 0. So here's my divider. This is going to be graphed on the right side, and this is going to be graphed on the left side. Less than left. Now, what shape do I have here for my first function? A line that's been dropped down 2. So normally the line would look like this, right? Well, now I've dropped it down 2, so it's going to look like this. Okay? Now, it hits the divider right here, and that's going to be an open dot. Would you agree with me?
No, yes, so.
Now this is the divider. So I need to erase either this side or this side. Look up at your problem. I'm going to erase the left side because I'm keeping the right side. Greater than. Okay? Now, what's next? What shape is that? That's y equals 3x. Isn't that also a line? And this one, no, be careful, Mackenzie. This would be horizontal. As soon as you put an x in there, it becomes diagonal again. Okay? So this is, the other one we had was a plain 3. As soon as you put an x in, it's diagonal. What's the slope of this line? 3 over 1. So we're going to start at the origin, count up 3 and over 1, down 3 and over 1. So this is a very steep line that looks supposed to be straight. Okay? Now, it hits the divider right here. Remember, this is our divider. It hits right here, right? That's going to be a solid dot or equal to. And I'm going to erase part of it. Which part do I want to erase? The right side. Because I'm keeping the left.
I'm looking at this completely wrong.
A dot. Every time it hits the divider, it's either going to be an open or closed.
So So are the lines, are the slopes of these lines?
So one will, they'll never be two closed dots or two open dots. Well, there could be two open, they'll never be two closed. So you're gonna have or equal to on one of them, and that will be the closed one. And the other one will be not or equal to. PJ?
So is the slope of the left line down 2 over 1, and then the slope?
No, the slope of the sine is 3.
All right, then.
The slope of the other line is 1. That's y equals 1x minus 2.
Yeah, okay.
Of 1 over 1. Okay? All right. Is there anything else in the packet that's not completed? I want to use this time to finish up anything that's not completed up through that
Do
part.
we have an upcoming test?
C and D on the first page.
Which one?
C and D.
On what page?
What?
Oh, the very first page.
Oh, yeah, we
Okay. Go back to the very front page of the packet. We've got a couple of equations we need to solve there. Very front page. We apparently never did C or D.
We started C.
Well, let's finish it. Here we go. What do you want? Very first page of the packet. Open the packet right there. Go. C. What do you want to do with this equation?
Distribute this.
Distribute the x. Very good. Then what, Sam?
And I want to subtract the 5 over it.
I would. I'd love to get my quadratic equations equal to 0. Because then what can we do? We've got some options now, don't we? Could be. Absolutely. This one does factor, doesn't it, Megan? This one does factor. So if you wanted to factor it, you could. Now what if, so your answers would be 5 and -1. What if you didn't want to factor it? You could use the quadratic formula, and your answers would be exactly the same, wouldn't they? So if you see it factors and you like to factor, that's always quicker. But if you would rather use the formula, you can. Thank you, Andrea. Put your head down. Keep your head up. This is way too important. All right, D. Who's got an idea for D? Problem D, equation D. All right, Lucy says, let's move those x's to the same side. So what is that, 4x squared? And can I go ahead and add the 5 to the other side then?
There you go.
Why not?
Let's just take the risk.
You only live once.
What might I do now?
You know,
Divide the 4 by both
I could
sides.
divide by 4, I absolutely could.
Now square them. Or
And I'm trying to figure out what x is, so I'll take the square root of both sides. And what do I have to remember over here? Plus or minus the square root of 15 over 2.
4 for 4.
No.
What?
What's the square root of 4? The
What?
square root of 4 is 2.
Oh, it came on the outside. Oh.
When I took the square root of both sides, I have to take the square root of the top and the bottom.
Makes sense.
And the square root of the bottom is just 2.
I didn't know you could do that.
Not only can you, but you have to. All right? Is there anything else in the packet that is undone?
1.3.
1.3 we talked about.
Yeah.
Yeah, I think we talked about all those.
Our last soccer game's tonight at home.
Yes. Let's go over our test. How much time do I have? Good time. Here come your test. Very good. Thank you.
No!
Miss Heron? Sean, would you turn it off?
Pass back the quiz to that ace that board.